The terrifying truth about black holes. Nobody talks about a star 20 times larger than our sun collapsed in less than a second. Every atom it ever contained, every particle, every quantum of energy, was crushed into a single point with no width, no height, no depth, just infinite density. And the thing that was left behind? It doesn't just sit there. It hunts. Right now, there are 4 million of them within our galaxy alone. 4 million objects that permanently erase everything they touch, and the universe keeps making more. But here's what nobody tells you. We don't actually know what happens inside one. Not really. Our best equations, the ones that predicted GPS satellites, designed nuclear reactors, built the internet, they don't just struggle inside a black hole. They collapse. They return answers like infinite and undefined. They break. Completely. And when your best mathematics breaks, that means something deeper is wrong. It means our understanding of reality itself has a limit. And black holes are that limit. This video is not going to tell you black holes are fascinating, you already know that. This video is going to tell you the things that keep physicists awake at night. The contradictions that have no solutions. The discoveries from the last 5 years that changed everything we thought we knew. And the one possibility, confirmed by data, not theory, that makes every other space threat look small. If you've never subscribed to this channel before, right now is a good moment. Because we don't do surface-level science here. We go where the answers get uncomfortable. Hit subscribe. Then let's continue. The first thing nobody tells you about black holes is the one that genuinely should disturb you. They destroy information, not just matter, not just energy, information. The specific, irreplaceable data that describes exactly what something is, what it was made of, how it was arranged. Every detail that made it that exact thing and nothing else. Here's why that matters. Physics has one absolute rule that has never been broken. Not once. Not in any experiment. Not in any equation. That rule is called the conservation of information. It says that information cannot be created or destroyed. It can be scrambled beyond recognition, but it's always still there, always recoverable in principle. This rule is the foundation of quantum mechanics. And quantum mechanics is the foundation of every piece of technology in your life right now. Throw a book into a fire. The book is gone, but the smoke, the ash, the heat, the light. If you captured every single particle and photon that came out of that fire, you could theoretically reconstruct exactly what the book said. The information survived. It's just spread out. Now throw that book into a black hole. According to Stephen Hawking's 1974 discovery, black holes slowly evaporate. They emit radiation, now called Hawking radiation, and they gradually shrink over billions of years until they disappear completely. But that radiation is completely random. It carries no information about what fell in. The book is gone. The information is gone. Forever. This is called the black hole information paradox. And it is not a minor problem. It means that either quantum mechanics is wrong, or general relativity is wrong. Two theories that have never failed a single experimental test. Both cannot be right. But we have no idea which one breaks, or how. Physicists have spent 50 years on this problem. They have not solved it. If you're finding this as unsettling as I am, subscribe. We're just getting started. Here's the second thing. Black holes are not rare. They're not exotic. They're not distant. The nearest known black hole to Earth is called Gaia BH1. It was discovered in 2022. It sits 560 light-years away. That sounds far. And it is. But on the scale of our galaxy, which is 100,000 light-years across, Gaia BH1 is essentially next door. It's in our neighborhood. And it was only discovered 2 years ago. How many more are sitting closer that we haven't found yet? Here's the honest answer. We don't know. Black holes don't emit light. They don't announce themselves. We find them by watching how they affect the things around them. Stars moving in unusual ways, light bending where it shouldn't, gas heating up and spiraling inward. We detect them by their gravity, their shadows, their consequences. The black hole itself is invisible. Our galaxy is estimated to contain between 10 million and 1 billion stellar mass black holes. 1 billion. And we've positively identified fewer than 100. That means right now, there could be a black hole 500 light-years from Earth, that we have no idea exists. And 500 light-years, for an object moving through space at several hundred kilometers per second, is a gap that changes over cosmic time. Not tomorrow. Not in a million years. But on astronomical timescales, the universe rearranges itself constantly. We are not looking for most of them. We don't have the tools to find most of them. And we wouldn't know one was approaching until it was already very close. I want you to think about that for a moment. Then I want you to subscribe, because the next thing I'm going to tell you is stranger than this. The third truth is about time. And this one bends your brain in a way that's hard to shake. Time near a black hole doesn't slow down metaphorically. It slows down physically. Measurably. Actually. If you hover 10 miles above the event horizon of a stellar mass black hole for 1 hour, you do not age 1 hour. You age minutes. Maybe seconds. Meanwhile, everyone back on Earth ages a full hour. Maybe more. This is called gravitational time dilation. And it is not science fiction, it is confirmed physics. It is so real that the GPS satellites orbiting Earth, 20,000 kilometers above the surface, experience weaker gravity than we do. Their clocks run faster. By 38 microseconds per day. That's tiny. But GPS systems must correct for this every single day. If they didn't, your navigation would drift by 10 kilometers within 24 hours. That's how real-time dilation is. It affects your phone. Right now. Now scale that effect up to a black hole. Enormously. At the event horizon, the point of no return, time dilation becomes infinite. From the perspective of someone watching you fall in from a safe distance, you never actually cross the event horizon. You slow down. You appear to freeze. You redshift. Your light stretches toward red, then infrared, then invisible. You vanish. But you never, from their perspective, actually fall in. From your own perspective, you cross it instantly. You don't feel anything special at that moment. For a large enough black hole, you wouldn't even notice. You'd cross the point of no return without realizing it. The moment you understood you were inside, the moment you looked back and couldn't see the universe anymore, it would already be too late to matter. There's no coming back. Not because of speed. Not because of fuel. Because space-time itself inside the event horizon points only inward. Every direction. Forward, backward, left, right, up, down. All of them lead toward the singularity. There is no direction that leads out. You are not trapped in a place. You are trapped in a future. And that future has only one destination. Subscribe right now if you want to understand how reality gets even stranger than this. Because it does. The fourth truth is one that physicists actively debate and rarely explain clearly to the public. The singularity, that infinitely dense point at the center of a black hole, probably doesn't exist. Not because black holes don't exist. They do. We have photographed them. We have detected their gravitational waves. We have watched stars orbit the supermassive black hole at the center of our galaxy for decades and measured its mass precisely. But the singularity is what the mathematics predicts when our equations break down. When an equation produces infinity as an answer, that's not a real physical prediction. It's a signal. It's the math telling you, your theory is incomplete here. This is where it stops working. Every time physics has encountered a singularity before, the resolution was the same. A deeper theory was needed. The Big Bang singularity, where all of the universe's matter and energy were supposedly compressed into a single point, is also considered by most physicists to be a mathematical artifact, not a literal description of reality. We don't have the theory to describe what actually happens there. The same is almost certainly true inside a black hole. Something happens at extreme density, something real. But we do not have the theory to describe what it is. We need a theory of quantum gravity, a framework that combines quantum mechanics and general relativity to know the truth. We don't have that theory yet. We have been trying to develop it for over 100 years. We have not succeeded. That means the most extreme object in the known universe has a center we cannot describe, a heart we cannot see, a truth we cannot yet access. And here is the thought that should stop you cold. Everything we see in the universe, every galaxy, every planet, every atom, was once compressed to similar densities at the Big Bang. The physics we don't understand inside a black hole is the same physics we don't understand at the birth of everything. Black holes aren't separate from us, they're a mirror. And we can't read what the mirror says. If that hit you as hard as it hit me the first time I understood it, subscribe. Share this video with someone who needs to have their mind broken in the best possible way. And let's keep going. The fifth truth is the one that science communicators almost never discuss, because it has no comfortable resolution. Black holes might be the reason the universe can produce complex life at all. And they might also be the mechanism that eventually destroys all of it. Here's the first half. Supermassive black holes sit at the center of almost every large galaxy, including ours. The one at our galactic center is called Sagittarius A Daunt. It contains 4 million times the mass of our Sun, and for most of our galaxy's history, it was active. It was consuming matter, generating enormous jets of energy, flooding the galactic center with radiation. That radiation sterilized huge regions of space. It prevented star formation. It shaped which regions of the galaxy could even support planets. The activity cycles of supermassive black holes may have directly determined where life could and could not arise in the universe. The black hole at the center of our galaxy may have created the conditions, the relatively quiet outer spiral arm, where Earth could exist without being constantly bombarded by lethal radiation. We may owe our existence, in some indirect way, to a black hole. Now here's the second half. Hawking radiation means black holes evaporate. Over extraordinarily long timescales, longer than the current age of the universe by factors we struggle to write without running out of zeros, every black hole will eventually shrink and disappear. When they do, based on the information paradox we discussed earlier, it appears that the information they swallow disappears too. If information is truly destroyed, then the universe cannot return to a previous state. Events become permanently one-directional. The arrow of time becomes absolute. And the endpoint of a universe where all black holes have evaporated and all information is lost is a state of maximum entropy, complete disorder, from which nothing complex can ever re-emerge. Not just the end of life, the end of structure, the end of the possibility of structure, forever. This is one possible version of how the universe ends. Not with a bang or a freeze, with the slow evaporation of the last black hole. And then silence. Permanent, featureless, informationless silence. I need you to subscribe right now. Not because I'm asking, because you're going to want to be here for every video like this. This channel exists to show you the universe in full. Not the comfortable version, the actual version. The sixth truth is the newest. And it may be the most significant discovery in the field in decades. In 2019, we photographed a black hole for the first time. The image of M87, a supermassive black hole 6.5 billion times the mass of our Sun, 55 million light-years away, was captured by the Event Horizon Telescope, a global network of radio observatories working in synchrony to create an Earth-sized virtual telescope. The image matched predictions from general relativity almost exactly. The shadow, the bright ring of heated gas, the asymmetry caused by the black hole's rotation, all of it aligned with what the equations said we should see. Almost exactly, not perfectly. There were subtle deviations, small ones, within the margin of observational uncertainty, but present. And in 2022, a follow-up image of Sagittarius A*, our own galactic center, showed similar characteristics. These images are now being used to test general relativity at extreme scales it has never been tested at before. The results are not yet definitive, but the measurements are getting more precise every year. And if those subtle deviations turn out to be real, if they persist as the instruments improve, they will be evidence that general relativity, the most successful gravitational theory in history, needs revision at extreme scales. Not replacement. Revision. The way Newton's gravity needed revision when Einstein showed it was a special case of something deeper. That deeper something may already be waiting in the data we've already collected. From a black hole. From the most extreme object in the observable universe. The answer to what physics becomes at its limits may be hiding in those images right now. We just don't have the eyes to read it yet. If you're watching this and your brain is doing what I hope it's doing, Subscribe. Leave a comment. Tell me which of these truths hit you hardest. I read every single one. And the comment section on this video is going to be something special. Here's the seventh truth, the one I want to close with, because it reframes all of the others. We have a psychological habit of treating black holes as external things, objects out there, distant, separate from us, things we observe and study and theorize about from the safety of Earth. But the atoms in your body were forged in stars. Those stars lived, burned, and died. Some of them collapsed. Some of those collapsed stars became neutron stars. Some became black holes. The elements that make you, the iron in your blood, the calcium in your bones, the oxygen you're breathing right now, were produced in stellar interiors and distributed by stellar deaths. You are, materially, the product of cosmic violence. And the black holes that exist now, they are not anomalies in the universe. They are the universe processing itself. Stars live. Stars die. The remnants that can't hold themselves up against gravity collapse without limit. Black holes are the universe's recycling system. Gravity's final answer, the state matter reaches when there's nothing left to stop it from compressing forever. Every black hole in existence was once something else, bright, burning, radiating, and then gone. And here is the thought I want you to take away from this video, the one that I think matters more than the paradoxes, more than the proximity, more than the information loss. We live in a universe where objects of infinite density exist, where time literally stops at certain boundaries, where the laws of physics break down and return no answers, where entire stars vanish completely and leave behind something that bends light, erases information, and shapes the structure of galaxies. And we are here, on a small planet, with brains that evolved to track predators and find food, and we are looking at these things and trying to understand them. And we are making progress. Slow, painful, sometimes humbling progress. We are building telescopes that function as Earth-sized instruments. We are detecting gravitational waves, literal ripples in the fabric of space-time caused by black holes colliding, with instruments sensitive enough to measure a change in distance smaller than a proton. We are doing this with physics, with mathematics, with human curiosity that refuses to stop at "we don't know." That is not a small thing. That is, on any honest accounting, one of the most remarkable things that has ever happened in this universe. Subscribe to this channel if that sense of scale, the genuine terrifying scale of what exists and what we're trying to understand, is something you want more of. Hit the bell so you don't miss the next one. Share this video with someone who thinks science is boring, because I want to see what they say after watching this. And leave a comment below with the one fact from this video that you are going to be thinking about tomorrow, because I already know what mine is. The nearest black hole we've found is 1,560 light-years away. We found it in 2022. We've confirmed fewer than 100 total. And there may be a billion of them in our galaxy alone. We are not looking for most of them. We wouldn't know one was approaching until it was very close. And the universe is under no obligation to warn us. Sleep well.